we've talked about covalent bonds, which were the first category of chemical bond. It involves the sharing of electrons, the strongest chemical bonds. They store a lot of potential energy. They are difficult to break. And remember, we had two specific categories: polar covalent bonds, in which there was unequal sharing of electrons, and non-polar covalent bonds, in which there was equal sharing of electrons. So covalent bonds were the first category of chemical bonds. Now we're going to start talking about the second category, called ionic bonds. And in order to understand ionic bonds, you first have to understand what an ion is. Okay, so when we look at the periodic table, every element as it appears here is called an atom. So that would be a hydrogen atom, a lithium atom, a sodium atom. And sodium, as an atom, has 11 protons in its nucleus and 11 electrons orbiting the nucleus. Okay, so it has 11 positively charged particles in the nucleus, and that cannot change. The number of protons in the nucleus of an atom cannot change. 11 electrons, negatively charged, orbiting that nucleus. How do I know that? Remember, atomic number. It's atomic number 11, so that means 11 protons and 11 electrons. And that means the sodium atom has no net charge. And if we draw the electron configuration of that sodium atom, I'm going to consider this to be the first electron shell, second electron shell, third electron shell. So 11 electrons. First shell holds a maximum of 2. So 1, 2. Second shell holds a maximum of 8. So now we're at 10. That means in the outer shell, sodium has 1 electron. And it has 7 spaces available. Remember, every atom needs a complete outer shell to be stable. In the case of sodium, sodium would have to share electrons with 7 other atoms. That is very unlikely to happen. In fact, it doesn't happen. Instead, sodium would rather give this electron away to somebody else. If sodium gives this electron away to another atom, transfer of electron, and guess what happens? This is no longer sodium's outer electron shell. This is now sodium's outer electron shell. And is it full? Yes, it has 8 electrons. It is a full outer shell. And now something happens to the electrical charge of sodium. This is what we call a sodium ion. The sodium ion, it's still going to have 11 protons in its nucleus. Remember, I said the number of protons cannot change in an atom. So it still has 11 protons, or positively charged subatomic particles. How many electrons does it have now? It gave this one away. So now it has 10 electrons. Now, positive charges and negative charges are no longer equal. And this ion has a net charge, and that's the reason it's called an ion. It has a +1 charge. Sodium atom, no net charge, equal number of positive and negative charges. No longer balanced, no longer equal, and now sodium has a net charge. And we indicate that with a superscript plus sign. That means it has a +1 charge. That means it has 1 more proton than it has electron, because it gave an electron away. That superscript doesn't have a 1 after it. Somebody decided in chemistry that if it's a 1, if it's a -1 or a +1, you just put the plus or minus. If it was a 2 or a 3, you would actually write the number. Okay, let's see who sodium might give this electron to. How about somebody who just needs 1 electron? Remember, for sodium, we sketched the electron configuration, but we could have also remembered that important shortcut. Sodium is in what column on the periodic table? It's in column 1. So that means it has 1 electron in the outer shell. How many electrons does an atom need to have a full outer shell? If we're talking about the second or third shell. It needs 8. So who needs just 1? Which column needs just 1 electron to complete the outer shell? It would be column 7. So column 7 needs just 1. So let's look at chlorine, atomic number 7. I'm sorry, atomic number 17. It's atomic number 17, it's in column 7. That means it has 17 protons, 17 electrons, no net charge. 7 electrons in the outer shell. Let's sketch it. Okay, first shell has 2. Second shell has 8. So now we're at 10, 12, 14, 16, 17. 1 spot available. Okay, so chlorine needs 1 to complete its outer shell. If sodium transfers that electron to chlorine, here's the little purple electron from sodium. Now what happens to the charge of chlorine? Remember, it's still going to have 17 protons. But how many electrons does chlorine have now? 2 plus 8 is 10 plus 8 is 18. So chlorine now has a -1 charge. And we would write that Cl-. So this is how we would write a sodium atom. And this is how we would write a sodium ion. This is how we would write a chlorine atom, and this is how we would write a chlorine ion. Remember, the difference between an atom and an ion is the atom is how it exists on the periodic table in its elemental state. Equal number of protons and electrons. It becomes an ion when that becomes unbalanced. When it either gains or loses electrons, and now it has a net electrical charge. If it's a positively charged ion, we call that a cation. If it's a negatively charged ion, it's called an anion. And now, what happens is opposites attract. So we've seen this concept of opposites attracting a couple of times now. That's what holds the atom together. That positive nucleus attracting the negative electrons. And now we are going to see 2 ions attracted to each other by this difference in charge. So here is how the ion forms. So that's step 1. Step 1 is the atoms have to become ions. This shows lithium, atomic number 3. It also has 1 in its outer shell. It's in column 1. And it's transferring an electron to chlorine to complete the outer shell. And here's the sodium story. Sodium transfers this electron. This now becomes its outer shell. Full outer shell, full outer shell. They're both happy in terms of having a full outer shell. They're stable. But now they're going to be weakly attracted to each other because of this charge difference. This cation is attracted to this anion, and that's what forms an ionic bond. So an ionic bond is an attraction between ions of opposite charge. Attraction between a cation and an anion. So if we were going to write the chemical equation for sodium chloride forming, we would have not a sodium atom, but a sodium ion plus a chlorine ion. And through ionic bonding, opposites attract, we're going to end up with sodium chloride. Sodium chloride is a compound. It does not have a net charge because the positive charge of sodium is going to be canceled out by the negative charge of chlorine. This is a weak association. You know you can mix salt and water and it easily breaks apart. What's important to understand here is how the number of electrons change. So here's a quick question. How many electrons are in a sodium atom? Okay, so the atom was the uncharged. 11. How many electrons are in a sodium ion? Important to understand the difference between those two terms. Sodium ion, 10 electrons. It gave one away. And now that's how it becomes an ion. If any part of that was confusing, please rewind the tape. And we're going to start talking now about hydrogen bonds, the third category of bonds for this course.